Welcome back, everyone. Welcome back to my math channel online today again. Before I get into the lesson, please let me remind you about visiting my mathteaching.ca I wrote on the top of this board. This is the website I post weekly lesson plans for free education. Also, some of the interesting poems or whatever I think that's nice pictures, nice short video. So that's my mathteaching.ca website. Or you can follow me on the course by register to mathcourses-online.teachable.com. When you register to my courses, you will have Zoom support if you have any question. Plus, you will be able to download on the sample solution and practice exercise to pursue mathematics education. So anyway, the lesson today we learn will be about solving polynomial function, which is included in my third project for pre-calculus math 12. I am thinking about the next project. I will choose a course which is the most useful to all adult students, as well as like students who would like to gain entrance to college or university, or would like to review the mathematics concept for general education. My next course probably will be about the mathematics of finance. Anyway, let me talk about the topic today, solving polynomial function. So on the board, I have wrote two equations. Actually, it should be equal 0 here, so we can solve. Okay, so to solve the polynomial function, first we can divide them down by a divisor, x equal x minus 1 or x plus 1 or 2x plus 2, whatever. Unfortunately, in this question here, they don't give us the divisor to use the long division to divide down and to factor it, to be able to factor it. So we have to make a guess. And we will make a guess based on the rational zero theorem we have learned in the previous video. So first, you have to know the factor of this constant, which is 5 times 1, and could be plus or subtract, right? This will be 2 times 1 plus and subtract. So if I use the number 5 and I plug in here, and I plug in this expression and it equals 0, then I will choose the number 5. If I choose the number 1, let's say by inspection, we want to make a simple guess first. So let's say if we put a 1 in here, if we put a 1 in here positive, the noting chain, that will be 2 minus 5, which is minus 3. Minus 3 with minus 13 will be us on the total negative, and we're not going to get 0. If we choose 1, we put in here, obviously it won't work as well. You can see that if 2 minus 5, if we choose positive 1, then nothing changes. So we have 2 minus 5, which is minus 3. Minus 3 minus 13. So the same scenario will be happen. So the number 1 factor here doesn't work out. So the only choice we have is minus 5. So let's check if we are okay if we choose positive 5 or minus 5. Now, my inspection, if I choose the positive 5, then this number is still negative. And this number will still be negative. So it's not going to outweigh and give us a 0. So if I choose positive 5, let's say if I choose positive 5, so let's try that. 2 to 5 to the power 3 minus 5 square minus 13 5 minus 5. Now, obviously, I don't believe it's going to be 0, right? This will be 2 times 125 minus 5 times 25 will be 125 as well. And this will be 65, right? And minus 5. So this will give us 250 minus 125. Then this will be equal 125. But then we subtract 70, right? 65 add 5, 70. It's not going to be 0. So we know that number 5 is not working as well. So what is the next choice we can learn? Now, in our rationalize zero theorem, we learned that we can use a factor of the constant number here, which is either 5 or 1, divided by leading coefficient. And the leading coefficient here is 2. So let's try that. Now, I'm going to choose number 1 first, right? And I'm going to choose, so our rationalize theorem say that we can have a factor of constant, right, divided by the factor of leading coefficient. So I'm going to try, right? I'm going to say I'm going to try factor of the constant is -1 divided by leading coefficient is 2. Factor of leading coefficient. So I'm going to try this one. So I'm going to put in p -1/2 into this expression, see if it works. So 2 times -1/2 to power 3 -5 times -1/2 square minus 13 times -1/2 -5. So let's check. This will become -1/8 over 8 this will become positive, so this is still negative, right? -5 over 4. So that is 1 over 4, right? Minus, and minus with minus become plus. So we have plus 13 over 2 -5. So this turned out to be, divide this. So I would got -1 over 4, right? Divide this with this. 2 divided by 8 is 4. -5 over 4 plus 13 over 2. I'm going to do common denominator for this, right? So I will have 10 over 2. Now this is the same common, so that equals 6 over 4 minus 6 over 4. This 113 minus 10 is plus 3 over 2. Now minus 6 over 4 equals 3 over 2 because you divide it by 2, right? Reduce the low fraction, this number the same like this number. You subtract them, you add them, 1 positive, 1 negative equals 0. So it works. If we use a rationalize theorem, we say, okay, we're going to try 1 divided by 2 and see what happens. And it's working. So now let's put in the synthetic division and divide this, right? So now we know -1/2 is working. So let's do it by synthetic division. So for synthetic division, I will copy this to -5 -13 -5. So that's the way we use synthetic, right? We just copy the coefficient number in front of the x letter. We don't have to copy everything. So now we do opposite with long division. The factor minus 1/2 will go in here, right? Bring the 2 down. 2 times minus 1/2 is minus 1, minus 5. Now we add, right? In long division, we subtract. Synthetic, we do opposite, we add. So 5 add 1 is 6 and should be minus 6, total negative. Minus 6 times minus 1/2 is positive 3. Minus 13 add 3 is minus 10. Minus 10 times minus 1/2 is plus 5. And minus 5 plus 5 is 0. So this will go down to one level because x3 divided by x, right, will be equal to x2, right? So that's the scenario. So we know this will be 2x squared minus 6x minus 10. So that's the scenario for this one. Now, at this point, we still can use synthetic, but because it's already going down by the quadratic function by degree 2. So why not try the degree 2 to see if it works, right? So we say 2 times 1, and factor this, 2 times 1, and then factor this 5 times 2. So let's see, 2 times 2 is 4, 1 times 5 is 6, 6 minus 4, we're not going to get that. So let's say if I change this, become 10 times 1. Obviously, it's not working as well. 2 times 1 is 2, 1 times 10 is 10, 10 minus 2, you're not going to get 6. So we know we cannot factor this expression. So let's use a formula, quadratic formula to solve this, right? So in our quadratic formula, x will be equal minus b, let's subtract b squared minus 4 times a times c divided by 2a. That's the formula. If we use a quadratic formula, we solve. So here we have x will be equal, our b is this digit, right? Minus 6. So it becomes positive 6. And subtract b squared will be 36. Minus 4 times a times c is 2 times a times c is minus 20. And divided by 4. 2a, right? 2 times a is 2, so it equals 4. So we will get 6, adding subtract with 2 root here, right? 36. Now 4 times 20 is 80. 80 add 36. So 80 add 30 is 110, 116 divided by 4. Okay, so 116, how do we get the exact value? We want to be answered in exact value. So 116 divided by 29. Okay, so this number can be change it becomes 6 plus and subtract 4 times 29. So instead of 116, I change to 4 times 29. So this will end it up 6 and subtract. The 4, I will take it out, right? Become 2. And inside, I left with 29. And divided by 4. Now, at this point, I can divide all of them by 2 to reduce, right? To lowest fraction. So I get 3 and subtract 2 divided by 2 is 1. Square root of 29 over 2. So that's the answer for x1 and x2, right? So we have 2 root, x1 and x2. So if we have to solve this using synthetic and then quadratic, we'll get the answer is x1 will be equal minus 1/2 x2 will be equal to 3, add with 3 adding with square root of 29 divided by 2, and x3 will be equal to 3 minus square root of 29 over 2. So this is the 3 root of this cubic function. We are using the synthetic division to find out how we're going to factor this, and we solve them by both methods, like x equal minus 1/2 by using rationalized theorem, and we use quadratic function. We get the second root and the third root. You can see this is degree 3, so we have 3 roots. That's reasonable. So that is how you solve the first question. So now I am going to show you how we solve the second question. But let me do something on my computer. It thought up something. So annoying. Okay, sorry about that. So now I'm going to show you how we're going to solve the second question here. And therefore, I'm going to have to erase all of this. So let's put in the answer. x1 equal minus 1/2. x2 equal 3 minus square root 29 over 2. And x3 equal 3 plus square root 29 over 2. So now let's find out how we're going to solve the next equation. So the next equation, you make sure you make the observation, right? If we have to expand this bracket in 4 of them, and we try to solve like this way, it's going to be very complicated. So when the question designed this way, all what you have to do is copy the expression x plus 5 to power 4 first, move these two numbers together, right, to the other side. So minus 40, minus 24, move to the right equation will become minus 24, plus become minus when you move over. And that will be minus 40. Copy it down, right? Nothing change. So now we have minus 2, x plus 5 to power 4 equal minus 64. Now at this point, we can divide both sides by minus 2. So we'll get x plus 5 to the power 4 equal positive 32. So in this situation, you solve by this way is a lot easier than using synthetic. That's why each question designed in the way that which algebra approach we should use it, right? So here at this point, you know that to solve for x, you have to take the 4 root of this number, right? So that you can cancel the power 4 with the root 4 here to bring the x plus 5 outside, right? Without the root anymore. And because we take the 4 root of the left side, we have to do for the right-hand side, same thing. But when you do this, make sure because we have a 4 root, you know that the answer will have 2 choices, plus and subtract, right? Not just plus or not just subtract. So let's subtract the 4 root of 32. I'm going to split this, become 16 times 2. Because I know I can bring out the 2 to the power 4 equals 16, and that 4 will cancel with 4, so it can bring out the 2 outside, right? Because this number is 16 times 2, and for the 16, you turn it into 2 to the power 4. This 4 will cancel with root 4, you can bring out the 2 outside. So you're left with the 4 root of number 2 inside. This is the one left inside. right? Because you cannot bring it out. So that's the idea. So now your x will be equal, move this over, you have minus 5, add 2 for square root 2, that x1, x2 will be equal minus 5, subtract 2 for root of square root 2. And what is our x1? Actually, we have a degree of 4, and we have the two answers like this. So they should be the same, like, what do we call? This should be, okay, so there will be x1 and x2 with the same answer like that. And this one will be x3 and x4 with the answer like that. Because this is the 4 degree, right? So we have 4 root is the answer. It's the same like parabola, right? So they might get at somewhere like this, but this one will be x1, x2 with the same root together. So the scenario is something like that. Okay. So this is how we solve the polynomial function, and I show you in 2 different ways. The next one I would like to show you is a different question, right? So I'm going to write down the question here and show you how we're going to do this. So let's say if you have the question, so this is question 3, is say working backwards, write a polynomial function with the given root. Okay, so they give us the root minus 3, 2, and minus 1. So how we do this question? Now you know that the polynomial function can be factored out, right? And when we factor out, we will have them multiply together in each bracket, right? Multiply them together. So we can try this like the same. We know the root here is root 1, root 2, root 3. So we know the n degree here should be x to the power 3. That's the degree because we have 3 answers, 3 roots. So the first bracket, we can establish our polynomial will be equal x plus 3. We have to change the sign to opposite, right? First. So when we set this equal 0 with solve, we can have x equal minus 3 like that, right? Time with the second root will be x minus 2. And time with the third root will be x plus 1. So this is our establishing polynomial function based on the roots of this equation. Now at this point, we're very much done. If we want to leave this in a factor form, if we don't want, we can multiply them together and get it written out, right? So let's say if I like to expand it, I will expand this with this. I will have x squared, so multiply 2 brackets first, right? We have x squared plus 3x okay, so I will have x squared plus 3x minus okay, so let's do 1 by 1 here. X to x squared minus 2x plus 3x, right? Plus 3x minus 6. So that will be x squared plus x, right? Minus 6. Now will be times with x plus 1. So if we expand this, we can write in this form as well. So we have x to the power 3, x times x squared, adding with x times x is x squared, minus 6x, and 1 times x is plus x squared, plus x minus 6. So simplify this, we'll get x to the power 3, 1x squared, add 1x squared is 2x squared, right? This one, minus 6 plus 1 is minus 5x minus 6. So you can answer in either way, in the factor form or in the expansion form. They both the same equation, right? So this is how we try the polynomial function. I have one more question I would like to show you in this short video. So one more question. Let's do one more, something like this. Right, so this is question 4. Write a polynomial equation with the given root, with given roots. So minus 4, minus 1, 2 over 3, and 2. So again, we're going to do exactly the way we do here. We have x plus 4 for the first term, right? The first root, times with x plus 1 for the second root here, right? And the third root here will be x minus 2 over 3, and times with x 2 minus 2. So how many degrees we have here? 1, 2, 3, 4. So we know our polynomial have the highest degree is x to the power 4. Now, because this is complicated and you already know how to expand the algebraic version, right? If you have to expand it, just tie them together, the first and second bracket to get the answer down here. Then time the second and third bracket to get the answer down here. Then multiply them again to get the final answer. So if you have to expand, you would time this bracket with this bracket to get the answer down here. Then time this bracket with this bracket to put into the answer down here. Then the final, you would time this together to expand them. And nothing difficult about this, it's just tedious task. You got to pay attention to the negative and positive, and add and subtract algebra, which we passed that already in this Math 12 level. So I'm not going to bother to show you the rest, right? Let's cut the video here and stay tuned for my next video. My next video, I will show you about how to solve the quadratic, not quadratic, how to solve the word problem, application of polynomial function. So see you in next video. Thank you for watching and bye for now.